Hi, I'm Lauren Millar. Tonight, we'll be preempting our regularly scheduled episode of the Science Edition to bring you a special program from and about space. We'll take an inside look at Canada's space program and a conversation with Roberta Bondar from orbit via satellite, coming up next on the Science Edition. Not since Marc Garneau's shuttle flight in 1984 have we spent so much time looking skyward and being proud to be Canadian, because this is only the second time a Canadian has been on board the NASA space shuttle, and in this case, it's the Space Shuttle Discovery. And that's just the kind of mission that Roberta Bondar has been on, one of professional discovery while she conducts scientific experiments in the first international microgravity lab, and it's also a personal discovery for Dr. Bondar. Since childhood, she's dreamed of being a scientist and an astronaut. So stay tuned for a conversation with Dr. Roberta Bondar aboard the Space Shuttle Discovery, somewhere in space. But first, here's Stuart McLean.
Hello. Roberta Bondar says she's dreamed of flying since she was 8 years old. There's something about flight that fascinates all children. There's something about space flight that touches the child in all of us. We're going to have our opportunity of finding out how Bondar's flight is going in about half an hour. And while we're waiting for the link-up, we thought we'd take a look at Canada's astronaut program. You might have seen the ads in last week's paper. The Canadian Space Agency is looking for new astronauts again. They chose the first 6 9 years ago. And when better with Bondar finally flying to take another look at them. This story was originally produced by the Science Edition's Craig Moffat. We ran it in our 3rd season. Here then, in their own words, are the Canadian astronauts.
Gone for main engine start. We have main engine start.
All the Canadian astronauts who fly on the space shuttles are known as payload specialists. Now, there's 3 types of astronauts that fly on the space shuttle. You have the commander and pilot, who are responsible for getting the space shuttle up and the space shuttle down and doing any on-orbit maneuvers of the space shuttle during a flight. Secondly, you have mission specialists. A mission specialist astronaut is a person who will operate, for example, the Canadarm, or who will do the EVAs or spacewalks. And the 3rd category of astronauts are known as payload specialists, and they are proxy investigators. They are trained by scientists to carry out the scientists' experiment on board the space shuttle or on board the KC-135.
Well, the role of the astronaut in interfacing with scientists is that because we know what the conditions are going to be like either on the KC-135 or up in space, we can make sure that they are aware of certain constraints, certain problems that they may run into in the design of their equipment. We know that when you're up there, it's not quite like doing the experiment on a lab bench down here on Earth. There are constraints of time, size, types of materials that you use, and we therefore try to bring that experience to bear.
I think it's very important for any country to have both a manned and unmanned component. In terms of the manned component in Canada right now, there are a number of valuable services that we've already rendered the community. One of these, of course, has been through the actual doing of science in space on the shuttle mission with Marc Garneau, and the rest of us will be training for future missions. That way, scientists are able to have a surrogate pair of hands in space to be able to perform the science experiments.
So even though we're a small nation when it comes to space, I think that we're very efficient. And I guess the Canadarm is the best example of that. For the biggest bang for our dollar was that particular piece of apparatus, and I hope that the same thing happens on Space Station, because we're building an instrument that will put Space Station together as well as to help and service payloads. And I think that's a very visible piece of hardware on the station, and since station is a condominium type arrangement where if you contribute 3 or 4%, you get back 3 or 4%, it could be very exciting.
We have a proud tradition of being in space, and I think that the government and the Canadian people are basically committed to our continuing involvement. The important point now to remember is that other countries are beginning to accelerate their efforts. For example, Japan and the Europeans, who are really a space power of considerable size. It's important that Canada doesn't get lost in the shuffle, that we do continue. My feeling is that we will continue.
Space research is something that is very difficult to put value on right now. It's like starting a whole new area of science and trying to extrapolate and have enough vision to see the applications in the future. We know right now for a fact that there are certain things we can do in space much better than we can do down here on Earth, but it's very expensive right now, very expensive endeavor. Young people see us as tangible examples of not only the space program, but also various fields of science, whether it's biology or engineering. So I believe that in the capacity of just, in terms of just the general interest, drumming up general interest in space research and development for the future generations, I think has been a very important contribution.
Canada has a very rich heritage in unmanned space programs. For example, 25 years ago, Alouette 1 was launched, and followed by other satellites that studied the upper atmosphere. Canada is a world leader in communication satellites, and also probably our most visible space achievement is the Canadarm for the Space Shuttle. These are all unmanned projects. From the feedback that we've got from the scientists involved in Marc Garneau's first flight, everyone has been very positive, saying that we are making a contribution to the advancement of science in their respective areas. And people are lining up at our door asking us to conduct experiments for them in the future.
It's very expensive to put objects into space, so you have to do a lot of design work and really analyze things very thoroughly. And that leads to the development of a lot of spin-off products, and the space program in general has done a lot of that. So, and it really is one of the major fields driving the development of technology, and it's really for that reason that it's very important for Canada to be involved in the space activities overall.
Our program will move very much towards the space station, and we are going to have the remote servicing center, and hopefully it will always be a Canadian who is working that. In order to take advantage of this new environment, we have to have people who are capable of going there and living and working and so on.
When you get up there and you look down and you can actually see your whole planet, not in one shot, but you can go around it in 90 minutes and go around it 132 times like I did and see entire provinces, see 1,000 miles in front of you, have that global perspective. You suddenly, of course, come to the realization that this is a fragile planet which sustains life, but it's the only life-sustaining planet for a long way. It's very dark and black out there in space. We can easily spoil our planet. We can easily destroy it. And suddenly you realize that it's important that we don't.
As Bondar said, one of the primary roles of Canadian astronauts is to be a surrogate pair of hands for scientists. The experiments that Bondar is conducting are being performed in the Space Shuttle's bay. Bondar and a German scientist are conducting experiments for 200 scientists from 13 countries in this so-called International Microgravity Lab. These and later experiments about how the human body and materials react in space are part of the process leading to the deployment of Space Station Freedom. Now, while a shuttle's the ideal place for extended studies of what happens to us in space, here on Earth there is another way to create short bursts of microgravity. Lauren Millar looked back in our files and found this report on an airplane that's used for both experiments and astronaut training.
More than 40 times a year, experimenters from across the Western world descend on a hangar at Ellington Field near Houston, Texas. For 1 week, a group of Canadians took part in an event experienced by only a select few, NASA's Reduced Gravity Program. Scientists worked with Canada's astronauts, performing a wide variety of experiments in basic science, materials processing, and life sciences, aboard the KC-135.
The KC-135 is an Air Force tanker. It's used by the Air Force for carrying fuel and delivering fuel to other aircraft in the air. We have modified it slightly for zero-G. We've done some things with the hydraulic systems and with the fuel systems in order to properly be able to operate the aircraft while we're flying. The aircraft itself has been in service continuously since 1959, and NASA took it over in 1973 for the zero-G program.
Generally, large companies that are making big pieces of equipment for spaceflight can come in and rent this aircraft for a week or 2 weeks or however they only need it, and it's just a small part of their budget. But most university-based and academic-based and small companies who want to just test out their hardware, want to do experiments, can't afford to do that. So what Payload Systems did was started organizing groups of them into missions together, and then we would go out and contract for the aircraft for the entire week or 2 weeks or whatever period of time.
The experiments are carefully designed and constructed to NASA specifications to fit and perform safely in the aircraft. A pre-flight inspection by a team of NASA engineers examines each experiment with an eye towards safety. The astronauts and scientists rehearse procedures in preparation for periods of weightlessness on the airplane.
We solicit experiments from across the country, from Vancouver to Halifax, and we ask the particular scientists whether or not we can help them actually operate the experiment. We receive training as operators. So although we may not be the initiators of the experiment, we have to know the theory behind the experiment very well. We have to know how to operate the experiment. So the training that we're getting this week on the KC-135 is looking forward to the day when we'll fly in the space shuttle and be doing similar types of tasks for other Canadian scientists.
To departure, turn right in 120.
On the morning of the first flight, the KC-135 rumbles out onto the runway. Tension is high. Months of preparation, hundreds of thousands of research dollars, and thousands of miles of travel depend on this 2-hour roller coaster ride over the Gulf of Mexico. Gravity is the glue that holds the universe together. It's a force of attraction that exists between two objects with mass. On Earth, the gravitational attraction is considered to be 1g. On the Moon, the attraction is 1/6 of that.
Contact light. Tranquility Base here. The Eagle has landed.
Mass, or the quantity of body matter, remains constant. So on the Moon, an astronaut has the same mass, but weight, the measure of an object's attraction to the Earth, changes. So on the Moon, a person weighs 1/6 as much. The orbiting shuttle essentially is in a free fall around the Earth. Gravity is constantly pulling it back. Centrifugal or outward forces created by the shuttle's velocity balance the effects of gravity. With this balance, the astronaut experiences weightlessness, also referred to as zero-G or micro-G. This phenomenon is also experienced on board the KC-135.
The zero-G maneuver is just a great big roller coaster in the sky where we start off flying essentially level. We pull the nose up and we go up to about a 45 to 50 degrees nose high attitude and then pitch over the top. As we start the pull up, we get about a 1.8 to 2G pull. That's 1.8 to 2G, 2 times the pull of gravity on your body. You pull up and pitch over, and as you get the pitch over, you get the zero-G phenomenon. And we're just balancing the pull of gravity with the centrifugal force of a arcing maneuver. And then we come on down the back side of the maneuver, and we pull out again with a 1.8 to 2 Gs.
for a period of about 30 seconds, we fly the same path that the body or anything else would naturally fall. And within the confines of the aircraft, you have weightlessness. It's not just an imagined thing, it's an actual physical phenomenon. And all the hardware, all the equipment, all the people, and everything within the aircraft are weightless for that period of time.
Lights on is the signal to all that the period of weightlessness is near. Under the watchful eye of the NASA flight crew, the experiments are readied. Once micro-G is achieved, the experiments are started and data recorded. Some of the experiments are designed to float freely during the period of micro-G, while others are securely latched to the floor. Micro-G will affect only the portions of the experiments on the inside. A cry of 30 over on the intercom indicates that everyone should prepare for the 2G period of the maneuver. An average flight contains 40 parabolas. After each flight, everyone gathers at Cajun Pete's for the traditional post-flight lunch. It's a chance to talk over the flight and discuss any modifications to equipment or methods. At night, experimenters make any necessary changes for subsequent flights. The Canadian contingent represents a cross-section of the work and laboratories across the country. One of the biggest concerns of space travel is how the human body reacts in microgravity. A major emphasis in the Canadian program centers on the effects of weightlessness on people.
Is to try and understand what we call the space adaptation syndrome. How long does it take to adapt to a microgravity environment, and how can you predict that a certain person on the ground who is totally immune to sickness in a 1G environment will or will not be susceptible to getting ill in space?
On Earth, both the eyes and the inner ear send information to the brain, describing the body's position relative to what we know as up and down. In a weightless environment, the brain gets conflicting information, since there is no relative up or down. This confusion may be one of the underlying reasons for motion sickness.
65 or 70% of people who've flown in the shuttle get sick. Some of them just feel rotten but don't vomit, but others vomit repeatedly. And they do habituate, though, after a few days, 3 or 4 days. And after they've done that, they're entirely immune. They won't be sick at all in the space environment. The experiment that we did today is part of that, to come to some understanding of how the eyes might be controlled in the torsional direction or mode by gravity, and what would happen without gravity. Perhaps that causes, or is a part of the cause of motion sickness.
While microgravity poses certain problems for humans, it presents incredible possibilities for processing materials.
There's no gravity, and therefore there's no convection. You can mix immiscible fluids together, and then they stay mixed because gravity doesn't separate them. You can produce perfect ball bearings in space flight because of the weightlessness.
On this flight, the experiments included one from Queen's University, designed to form alloys of metals that won't mix on Earth. The University of British Columbia performed an experiment separating biological materials using a weak electric field. Canadian Astronautics Limited produced 2 perfect liquid spheres, one inside the other. This could lead to the development of a potential cure for diabetes. The Ontario Research Foundation generated various sized ceramic spheres. These uniformly round ball bearings may soon find many applications on Earth. It's been predicted that materials processed in space may well mean billions of dollars in the future. However, the dream hinges on the ability of researchers to overcome the negative effects of microgravity on people.
The work that Bonder and the other astronauts have been doing on this mission will go a long way to fulfilling the promise of manufacturing in space. And Bonder's love of flying isn't just restricted to the shuttle.
I've been interested in hot air ballooning, I guess, for about 2 or 3 years. When I knew that it was highly likely that I'd be able to take a shuttle trip, I felt that it would be kind of neat to go up in almost the first type of lighter-than aircraft.
Are you ready?
Okay, guys.
Phil is an instructor, is a very responsible individual, very concerned about safety, wonderful teacher, a very good organizer, very well respected and cared for. In fact, at the time when I met him, I really asked him if he knew of anyone in Albuquerque who could help me obtain a balloon permit on my pilot's license. And I think he was very interested in the idea and decided to do this himself. And for that, I'm very grateful, and he's been absolutely wonderful. In ballooning, the next most important person to the pilot is the ground crew chief. This individual has the responsibility of coordinating, caring for the balloon. I mean, it's a social thing. Everything revolves around this big envelope and this wicker gondola, and sort of everybody else sort of, you just really function to support that.
Okay, let's just stand it up and do a burner check.
In the United States, their balloon requirements are, I believe, slightly different than in Canada, and I felt that I would like to take my time doing the ballooning. I would like to learn in a situation where there are a lot of people flying balloons, so I can observe and learn by observation as well. The whole idea behind having that much flame, like it's a big flamethrower, and you sort of move it around, you gimbal it around like you're stirring a pot of air with this thing. I was afraid that I wasn't going to have enough strength to lift the thing up. I didn't really have a proper appreciation of how much lift you get so quickly with the air, with warming that air, because it took the weight of the frame and the basket right off me. Like, that's over 200 pounds.
Go ahead and burn some more.
Okay. Once you achieve the same wind speed as the surrounding air, then you don't rise anymore unless you put more heat into the envelope. And sometimes that's a problem when people first inflate and take off, and there's a problem because there are power lines and they think they can rise above it, and suddenly they lose their lift because of the differential in the speed has disappeared. So it's a matter of keeping a differential in temperatures, that you want something warmer inside than outside the balloon.
We'll go ahead and cross the river, so go ahead and take the sail bridge.
We have a radio in the balloon and one in each of the two chase vehicles, and this is very much for safety. If a balloon runs into trouble and it has to land, you can give directions to the crew as to where it is you are flying.
Look for some of those open spaces out to the left.
Okay. Albuquerque is an unusual place in North America, so it appears, because they have very, very stable weather conditions in the morning, apart from the odd canyon wind that might come roaring down. But by and large, it's a very safe area because it's very, very big. It's very, very open. The city themselves has leased the Balloon Fiesta Field for the 2-week period on a once-a-year basis. It's a wonderful place. The weather conditions are such that it makes it very, very, very nice. Ground crew people have they have a great deal of responsibility, and it's the same kind of thing in research. You have a backbone of people that you can have for minimal, I think, a very good collaborative project. But those people themselves, if you get into any type of condition where it's sort of off nominal or it's out of the ordinary, you really do need to have more support and people that will supply answers. And in the ground crew, it's great if you've got an extra person on the crown line or someone else who can go around and make sure there aren't any holes that the pilot has missed or the ground crew chief has missed in the balloon while you're inflating it. It's a very social thing. Actually, being in the ground crew itself can be as much fun or more fun than actually being in the balloon. And I say this because if you're in a situation where you're in a four-wheel drive vehicle and you have to go up and down these washes or wherever on the back roads, it's a navigating skill. The person who's in the front on the seat on the right side to navigate the roads, and the person driving to make sure they can drive without knocking everybody out of the back of the truck. So it actually becomes really fun, like being on a modern-day pack horse.
Yeah.
It was really fun. I enjoyed it.
And now from Roberta Bonder, flying some 150 meters above the Earth in Albuquerque, New Mexico, to where she's floating 300 kilometers above the Earth in the Space Shuttle Discovery. We're very pleased tonight to present a special conversation with Roberta Bonder, direct from her vantage point in space. Speaking with her is Prime Minister Brian Mulroney in Ottawa and the Minister for Science, William Weingard, from the Ontario Science Centre in Toronto. The Science Centre is hosting a special event to celebrate the flight, so let's join them for what must be the highlight of the evening.
Toronto, Houston, please go ahead with your call.
Discovery, this is Toronto for Commander Ron Graby.
Toronto, this is Discovery, Commander Ron Graby speaking. Your voice quality is loud and clear.
Good evening, Commander Graby. This is Jay Ingram at the Ontario Science Centre in Toronto. Prime Minister Brian Mulroney is standing by in Ottawa, and the Minister for Science, William Weingard, is with me, right beside me here in Toronto. Congratulations to you and all your crew on a very successful flight so far.
Well, Jay, on behalf of the entire crew of IML-1, we'd certainly like to thank you. We have been very fortunate so far. The flight's gone very well. We're very pleased with that. At this point, I would like to turn things over to and introduce Dr. Roberta Bonder.
Good evening, Jay.
Hello, Dr. Bonder. To start things off, the Right Honourable Brian Mulroney, the Prime Minister, is waiting in Ottawa, and he's ready to speak with you right now.
Good evening, Roberta, and congratulations on becoming Canada's second space traveler. As you know, this is a year of celebration in Canada, our 125th birthday, and your flight has captured the imagination of all of your fellow Canadians, probably in a way that you couldn't have imagined. And the success of this international mission has demonstrated to the world that anything can be achieved with dedication and cooperation. And I'm delighted to have this opportunity to congratulate you on what you and your colleagues have achieved so far, and to wish you all well.
Thank you very much, Mr. Prime Minister. It's been indeed an honor and a privilege to be on board this particular mission. We've had a great deal of science accomplished so far in this flight, and we still have a couple more days, we hope, to be able to do a little bit more. We've enjoyed being with each other and working with each other and learning new things about the world and about how we work and how we view science. And it's just been a fantastic experience, and I just can't wait to get back and start telling people all about it.
Roberta, I spoke earlier today with Ken Money, who told me that you had spent a little time just studying countries as they went by. And I understand that you caught a glimpse of Canada during your mission. What struck you most during the sight?
Well, at lunchtime today, I had a tape on, I had a cassette tape on at the front, and I actually had a recording of, that I had recorded for me before I came up here of Canada. And I just happened to go up to the flight deck, and we were going right over Canada, and it was just fantastic. Although it's wintertime, and we were going over the northern part of Canada, we went across the Northwest Territories, down across into Quebec and Ontario, and you could certainly go back and you could recognize all the land features. It was just absolutely fantastic. There were very, very few clouds around. And I must say that for people who think that our country when it's wintertime is not exciting, let me tell you, it's exceptionally exciting from space. Very, very clear. And I just can't, I wish I could just have a foot down and walk across every mile of this beautiful country, because it just looks so exciting from up here. It's just beautiful.
Roberta, vous êtes dans l'espace depuis déjà 7 jours. Est-ce que la vie dans l'espace est très différente de la vie sur Terre? Parce que vous venez de dire que un peu mon pays, c'est l'hiver.
Oui, bien sûr, il y a beaucoup de différences dans l'espace. Par exemple, pour les repas, si vous voulez, c'est possible de manger le yogourt, par exemple, mais c'est possible dans l'espace de jouer avec la nourriture. Par exemple, le yogourt, c'est comme ça. Avec le cuir. C'est pour le repas, c'est nécessaire aussi de fixer solidement sur le mur, le plancher, le plafond. Sur n'importe quelle surface, on doit utiliser, parce que c'est la même chose. Le mur, c'est le même que le plafond, le plancher, c'est la même chose, et c'est très intéressant.
C'est excellent pour la diète.
La diète, ce n'est pas exactement comme la cuisine francophone, mais pour l'espace, il y a les petites bonbons de sirop d'érable, par exemple.
Roberta, Canadians across the country have been following your mission with great interest and pride. I wonder if you have a special message for them tonight.
Well, I think our country has much to be proud of in terms of things we've accomplished for our own country, especially in the field of science. I'm very, very proud to be a Canadian as part of this crew. And I think that all Canadians should be very pleased with the things that we do, different things, the variety of things we do, and the wonderful things that we share in our culture and our spirit. I think our country has great potential, and I think it's up to each one of us to be sure that we achieve our potential, especially the young people.
Well, Roberta, all Canadians are proud of you and what you've achieved, and I'd like to congratulate your other crew members as well on this splendid achievement, and on behalf of all Canadians, wish you all a very safe journey home. God bless you all.
Thank you very much, Mr. Prime Minister.
Mr. Prime Minister, on behalf of the entire crew, thank you very much for those wishes.
Dr. Bondar, this is Jay Ingram back in Toronto again. Thank you very much, Mr. Mulrooney. I have with me the Honorable William Weingard, the Minister for Science, and I think he'd like to take over and talk to you now.
Well, Roberta, it doesn't seem possible that when you graduated from the University of Guelph, that all these years later we would have the opportunity to talk like this. It is quite thrilling for us. I have 700...
Thank you very much.
700 people in the Ontario Science Centre, 200 of whom are children, many Girl Guides. They have asked me to ask you one special question. What's it like up there?
Well, it's very, very exciting. It's really something to be able to just float around and drift around and just sort of at nighttime not worry about your pillow or your bed. And you have to have good buddies like Commander Graby here to grab you back down to earth a bit up here in space. But the most exciting part of it, besides working the science, is to be able to have some perspective on where we are in the world today and to be able to look down from space on a beautiful planet. There is a crisp, beautiful, clear, brilliant blue atmosphere that we see, and we see it all the time. We have been in the sunlight on the orbiter for days. We haven't had night for a while. We haven't had the darkness shine on the orbiter yet. And it has been absolutely incredible looking down and seeing all the countries without boundaries, everything blended into one. And you can't see people down there. Sometimes you can see the results of the work that people have done. But for the most part, you get this incredible feeling that the whole world is such a unique place and is all one. And we should try to preserve it that way. And I really feel very, very strongly that we are certainly an all-one planet.
Some of the children also have an interest in the Canadian IMX motion picture camera. They want to know if it's still functioning well on its 9th journey into space.
It's functioning very well. In fact, we've had a lot of fun taking some IMAX footage of the work we've been doing here. Commander Graves is just going to come over and get a film canister. This is what it looks like. Now, on Earth, of course, I wouldn't be able to lift it like this. But in space, it can float by itself. So we're trying to get footage up here on what it's like to actually live up here, the kind of science that we need to do in order to be able to understand what it's like to be in space and to help us solve some of those mysteries that we've discovered. And actually, what we've discovered in this site, there are a lot more mysteries that have to be looked into and questions raised and problems and experiments to solve in the future and years ahead. So I think that for the IMAX filming, it's going to be most exciting to be able to see this laboratory, hopefully on the screen one day, and you'll be able to see more clearly the kinds of things we'll be able to do in the last few days up here in space.
Thank you. One last word from me, Roberta. I must say that your somersaulting on Sunday was much more interesting than the game.
Well, thanks very much, and I want you to know that Yankee tender and Canadian tender are worth the same up here.
This is Jay Ingram again, Dr. Bondar. Thanks very much for taking the time to talk to us, and thank you also, Commander Graby, for setting time aside for us to be able to talk to you both from Toronto here, William Weingart and myself, and for the Prime Minister, Mr. Mulrooney in Ottawa. Thank you very much.
Thank you.
Thank you.
The flight has been very successful, so much so that NASA extended the mission for an extra day. Bondar literally applauded that decision. She's been working very hard, rotating through 12-hour shifts in the microgravity lab, and she's enjoying every minute of it. The 7 astronauts involved in the mission are a very good example of the internationalization of space. With the 5 Americans are Bondar and Ulf Merbold, a German astronaut from the European Space Agency. On the ground, there are more than 200 scientists from 13 different countries. They have designed the experiments and assist where they can while the experiments are carried out in space. Analysis of the results will take anywhere from a few months to a few years once the shuttle has landed. One of the more unique and personal touches in the shuttle flights are the items that the crew members take with them. Bondar took music tapes that include her aunt playing the organ and her high school band from Sault Ste. Marie. She took her brownie wings, the crest from the Royal College of Physicians and Surgeons, Ontario and Canadian flags, and a piece of hot air balloon, even her stethoscope. A very special item on this flight is a Los Angeles Dodger baseball cap that the team members have been sharing. The cap belonged to Sonny Carter, one of the original crew members who was killed in a commercial air crash last year. The cap will be returned to his family after the flight. At least his spirit flew with the team. A crew from TV Ontario's science unit has followed Roberta over the past few years while she prepared for this mission. Working that closely with her, what impressed us most is her passion for science, her sense of adventure, and her deep concern for this planet. We'll continue to follow Roberta's career and wish her all the best in the new challenges that I'm sure she'll take on. But now, before we return to Stuart, we'd like to show you what the astronauts can see from the shuttle and listen again to what Marc Garneau felt when he first saw the Earth from space.
When you get up there and you look down and you can actually see your whole planet, not in one shot, but you can go around it in 90 minutes and go around it 132 times like I did and see entire provinces, see 1,000 miles in front of you, have that global perspective. You suddenly, of course, come to the realization that this is a fragile planet which sustains life, but it's the only life-sustaining planet for a long way. It's very dark and black out there in space. We can easily spoil our planet. We can easily destroy it. And suddenly you realize that it's important that we don't.
No one who knew her was surprised when Roberta Bondar was chosen as one of the 6 original Canadian astronauts. She wasn't a pilot, but she sure had an impressive resume. She's both a medical doctor and a PhD, and she's managed to keep up her medical and scientific research along with her astronaut training. In the years to come, continued exploration of space is going to open up a variety of new careers. Most of them will never involve leaving the ground, but all of them are going to require specialized training and education. Last year, Lauren Millar filed this report on the summer session of the International Space University held in Toronto.
No longer is space the realm of one particular nation. The expense and technological demands of space travel no longer allow nationalism to be the driving force. International efforts are necessary if we're to visit the moon again, or perhaps in the next century, to explore Mars. Even the development of orbiting stations like Space Station Freedom will have to be an international effort. With the United States leading the way, the project involves space agencies from Canada, Japan, and Europe. For this international cooperation to succeed, a special understanding is necessary for people of different cultures to work closely together. The long-term friendships and bonds developed as classmates can be used as role models. At this convocation, students are receiving diplomas from a unique institution, the International Space University, or ISU. The ISU was conceived by a forward-thinking group from Boston who shared a common vision of the future of space exploration.
We had a dream of going to find the top leaders of the next 21st century and working with them. Each of us have different qualities and different interests in space. And we saw no program that existed out there that had the breadth and scope of the education that we would like. Consequently, we put forward an idea of starting a university that dealt with all topics related to space and dealt with all nations interested in space. Had a founding conference back in April of '87, and just 12 months later, had our first session at MIT.
In the summer of 1990, the third ISU was convened at York University in Toronto. It's not a static institution. The ISU has succeeded in growing not randomly, but along a predetermined path. Like the missions it teaches, there's a multi-phase plan for the university and its future.
The first phase is a migratory phase in which ISU is a summer session program which takes place in a different country every year, thus bringing a wake of enthusiasm behind it and allowing the momentum to build for the concept of the International Space University. This is a 5-year program which takes us from the inaugural year in 1988, which was in the United States, through to the second session, which happened last year in Strasbourg, France. This year, of course, we're here in Canada. Next year, we move on to Moscow and then Japan.
Students who attend the ISU come from a variety of disciplines. They aren't simply from engineering and space science, but have undergraduate degrees in medicine, life sciences, architecture, business, and law. It requires extraordinary academic records to be accepted. The students must also have strong leadership qualities and a commitment to space development.
We have to have people that we think are going to show some leadership potential so that when they do pursue a career, that the chances are they'll attain some senior position, either in government, industry, or university. And we also look for interpersonal skills, and that shows up actually in the essays that they write. Because again, you're looking at people who have to interact with colleagues from various cultures from around the world in a fairly intensive program over 9 or 10 weeks. And we have to be fairly certain these people are going to work well together.
In only a few years, the ISU has developed an international reputation. The annual enrollment has reached an average of 130 students. This past summer, the Canadians hosted students from 30 countries. The 4 students here at this lunch table are typical of those drawn to this summer of intense study. Svetlana Odintsova is from the Moscow Institute of Physics and Technology. Sarah Fryer is from the United States. She recently participated in the Space Life Science Training Program at the Kennedy Space Center. Michael Oetlekew is from Bern, Switzerland, and is a physicist at the University at Bern. Philip Charest is from Quebec City. He's been studying at the Institute for Aerospace Studies at the University of Toronto. Over the first few days, everyone had a chance to meet and share their expectations and excitement.
The multicultural aspect of the whole program is quite challenging and quite interesting, especially knowing that people you will be working with this summer are leading personalities from 30 countries around the world.
I would like to meet many scientists around the whole world to speak with it about urgent problems of space engineering and space technique.
I also hope to learn some more about space, things I normally wouldn't learn in my field. I'm also interested in biology, so I hope to learn something that's related to space biology.
Well, I think that international experience is the most precious thing that I'll take away from ISU. Already, it has afforded me an incredible opportunity to learn about different countries and different approaches to solving problems.
There's almost an evangelical feeling that pervades the campus. Students and faculty honestly believe they can change the world and do it through space exploration.
It's the experience, the chance to be part of a challenging enterprise, and in a sense to bring together cultures, disciplines, people of vision who have never had a chance to meet before, and watch the magic. The sparks are flying, but in the most positive, creative way you can imagine. It's a new experience, it's a new optimism for the world, and I think as that happens in space, it'll spread out into every other field of endeavor.
If you go to a traditional university, such as my own university, for example, we're highly specialized in space technology and some aspects of space science. We do not have programs that are related to space, but involved with policy and law and business administration and life sciences and medical sciences. However, in the ISU format, people from all these disciplines can work together, share the knowledge, and participate in the lecture series, both at a generalist level as well as a highly specialized level.
During the session, the students spend more than 240 hours in the lecture hall and 280 hours on their design projects. The ISU attracts top professionals from the international space community to teach the courses.
In a sense, many of our faculty are self-selected. They pioneered a course at their university, and what we did when we started the university is approach each one of those people, one after another, invite them to do this. To many, it was almost a dream. They couldn't believe it. And then under one roof, suddenly they saw their peers, their experiment as a course suddenly gained a sense of credibility in contrast with the other courses that we were offering. And from that pool, then, a number of new faculty members have been added. We almost have now an ISU family of faculty, and I think from 16 countries, that shows a very broad range.
One of the summer lab projects demonstrates remote manipulation of equipment in real time over long distances. For example, the moon is so close to the Earth that it's possible for people in Toronto to mine the lunar surface without physically leaving the Earth. This teleoperations experiment was set up so the students could have an opportunity to control the equipment as if it were on the moon and they were on the Earth. For business students, these technical experiments were a new experience. For the engineers, policy and management issues were eye-openers. For all, the days were long. A lot of material had to be crammed into the short summer session.
It was very intense. I learned to appreciate coffee, and I wasn't a big coffee drinker before coming here, but I've been drinking a lot of coffee to stay awake. But again, in those moments where you're working intensely, that's where you develop some close ties with people.
Being from a life sciences background, it was really interesting, sometimes very difficult learning about the different disciplines like engineering and law and business and management. But it was wonderful because things that I never would have thought of as a life scientist, now I'm more sensitive to.
A feature of each summer session is the design projects. 2 projects are chosen each year that incorporate all disciplines, involving computer animation, peer review, and a written report. The ISU carefully selects the design projects so all countries will have an equal interest in participating.
This summer, International Space University has 2 design projects. One is called the International Asteroid Mission, and the other is called the International Program of Earth Observation. The purpose of these projects is twofold. One is to give the students hands-on experience in working together in a variety of disciplines to complete an actual project in aerospace. And the second purpose is to actually advance the state of the art in the 2 fields involved.
The International Program of Earth Observation monitored the Earth's climate and environment through a series of interconnected satellites and ground stations. The second project, the International Asteroid Mission, examined a near-Earth asteroid to determine if its minerals and metals could be mined for space construction. The end result is a computer-animated representation of the concept, but the important part of the exercise is the work done in research and development, and the teamwork required to finish it.
People from business, management, and law are critical to these projects on a number of different levels. First of all, the projects require management themselves, and so the management students get a chance to try in simulation and in a very intense 10-week time period their skills. They get to try managing complicated projects with people in lots of different areas and also from lots of different cultures. And it turns out a Japanese management style is very different from a U.S. management style, and they have to learn about that, and it causes a lot of anxiety in the first few weeks. And they come up with a modus vivendi, a way of living together and working together.
By graduation, the students have developed a circle of colleagues that could serve them well in their future work. Combining the North American concept of alumni support and the 80s concept of networking, the ISU offers graduates more than just academics.
What we are getting out of ISU is probably the most valuable thing that anyone in space can have, and that's the contacts around the world, a knowledge of who these next generation of leaders are, the top-notch individuals in space programs in various nations or corporations, or the top university researchers. So it's these personal relationships that is really the basic essence and most valuable aspect that I take out and the students take out of the program.
Since we broadcast that report, the Ontario government has come out in support of a bid to make Toronto the permanent home of the International Space University. All this stuff seems commonplace today. Young people looking for careers in space, chats between astronauts and people on Earth, the Canadian Space Agency recruiting a new generation of people who have the right stuff. It's hard to believe that it was just 31 years ago that Yuri Gagarin became the first human being to venture into space. For a while in the early 60s, we all used to get up early in the morning to watch space shots and liftoffs. But somewhere between Neil Armstrong's first step on the moon and this technology-crazed age that we live in, the idea of space and space exploration has become almost humdrum. Even with space travel being taken for granted, we can't forget that the people who venture into space are explorers. And to understand the bravery that it takes to strap yourself onto a huge tank of high explosives, we only have to look back 6 years ago this week. That's when the Challenger exploded 73 seconds above the launch pad, killing all 7 crew members. Space has spawned a number of cliches. There's Neil Armstrong's one small step for man, Star Trek's To Boldly Go Where No One Has Gone Before, Tom Wolfe, The Right Stuff. When thinking about the people who led the way during the first 3 decades of space exploration, those cliches don't seem out of place. On behalf of all of us here at the Science Edition, I'm Stuart McLean. Good night.
12, 10, 9, 8, 7. We have a go for main engine start. We have 3 main engines up and running. 3, 2, 1, 0. And liftoff. Liftoff of the Space Shuttle Discovery and the first International Microgravity Laboratory.
Houston is now controlling. Discovery and crew are rolling on course. Roll program. Roger, roll, Discovery. Roll maneuvers complete, placing Discovery and crew heads down on the proper heading. Engines at 100%. Back now to 70% to help maintain optimum aerodynamic conditions as Discovery accelerates through the lower altitudes.
You're watching TVO.
The Ape Trade, the documentary that was scheduled for this evening, cannot be aired tonight because of legal problems. We hope to be able to show it to you as soon as possible.